Hi everyone, my name is Varun Gautam. Today I want to present to you my project, AI-based Discourse Analysis System. I, alongside Dr. Nazreen Tepozaki and Dr. Soon Lee, am currently working on developing this system. Introduction. In science classes, teachers need to develop the students' ability to be able to differentiate between scientific and general thinking. To nurture this, educators often engage students in discussions centered around scientific studies and topics. To assess their growth, there is a requirement for a formal feedback system. This is done with the help of Classroom Discourse Analysis Tool. This powerful tool provides a conscious and accurate discourse analysis based on audio transcripts of a science classroom. However, this process is done manually, which leads to human errors and not able to get a timely feedback. To solve these problems, we propose the idea of developing this automated system that can provide the feedback instantaneously with no errors and less work for the teachers. Our objective is to deploy a user-friendly web-based application that is free to use for all teachers across the nation. The data that we currently using is collected from K-12 science classrooms across multiple high schools in the US. This is the structure of data. The data consists of the following attributes such as spokesperson, the dialogues, and the labels. We get to know more about these labels in the coming sections. This is the high-level representation of the entire automated system that we plan to fully build in the near future. The audio transcripts are being uploaded to the website by teachers, and the website then sends the data to the LLM model, which transcribes the entire data and then classifies the data based on the guidelines it is provided, and it will then send all the data to the database, and from the database the data is then again called into the website from where teachers can access the classified transcripts. As we have seen in the data, each sentence is categorized into two labels: type of utterance and reasoning component. The type of utterance defines the flow of text. For example, it helps in classifying whether the text is a question by a teacher or a response by a student, etc. The reasoning component defines the type of sentence, whether the text belongs to the discussion or not. In the TOU label, that is type of utterance, the classes change based on the spokesperson. As we can see, for teacher, the classes are question, prompt, example or explanation, feedback, which is then categorized into confirmatory feedback, feedback with a statement, and feedback with a question. And the last tag is for the sentences which are meaningless or inaudible. And for students, it is response, that is further categorized into confirmatory response, response with a statement, and response with a question. And the second label is NA, that is inaudible or meaningless. Then for the classes of reasoning component, RC are experience, scientific knowledge, observation or data, patterns from data, models or theories, and sentences that don't belong to any of the above categories, NA. We first went with fine-tuning LLMs such as Google's BERT and OpenAI's GPT 3.0, 3.5, since these models are already pre-trained on English datasets and they can easily understand the language. So for this, we first clean the data by filling out the empty null values and also combining subcategories of response and feedback into their respective original classes. This decreases the number of classes that the model needs to classify, therefore increasing the model's accuracy. But even after doing this, the results that we got were not up to the mark. However, to improve the results, we then utilized the prompt engineering method on GPT 4.0. We thought instead of raw training the data we wanted to guide the model in understanding how it can classify the data with seeing the data for first time. And as we have said before, these LLMs are already trained on large amounts of English dataset, so they can understand human language, human way of speaking. So we chose GPT 4.0 since it is the latest and most powerful LLM in the current timeline. So the accuracy of the system improved and the results were up to the mark. However, since our goal is to provide a free to use system, we opted on using Llama 2 by Meta as it is an open source model. So these are the guidelines that we use for both the prompt template and for both the GPT 4.0 and Llama 2. This is the test dataset that we have used for GPT 4.0, and this is the prediction that is done by GPT 4.0. This is the prediction that is done by Llama 2. Conclusion: as we have observed, even though GPT 4.0 provides accurate results, it is costly and sometimes it takes more time to get the results, as we have to get response from their servers, and the servers may get busy sometimes. Also, the problem with Llama 2 was, even though it's open source and free, and even the accuracy is as good as GPT 4.0, the number of tokens or the input size that we can send to the model is limited to 4096 tokens. Because of this, we are only able to test a small amount of data. So since we were able to provide good results with Llama 2, the only problem was the amount of data that needs to be sent into the model. For this, we thought of reducing the size of prompt and yet keeping it as informative as it was, so that we can input entire audio transcripts of a classroom discussion. And once the model is ready to use, we plan to deploy it on KSU servers with a user-friendly interface. Thank you.